This lesson is 7.1 about powers of 10 and fractions with powers of 10. I didn't bring home the manipulatives I would have shown you in class, but here's pictures of them. This grid has 100 little squares in it. We know that if we counted 10 rows and 10 columns, we'd see there's 100 little squares, but we'll call that one unit, one mat. If you split that mat into 10 equal pieces, you'd have this one strip. So this is called a mat, and this is called a strip. You could even divide this strip of 10 squares into 10 smaller pieces, and there'd be one of them, and that's called a unit. Those names not terribly important, except you'll see them in your textbooks. But you do need to know the fractions. This is one whole mat, so this is only a tenth of a mat, and this is only a tenth of the tenth, which means it's 1/100th, just one of those, 1/100ths of the whole thing. Here's another way to look at it. We could have a cube that's 100 on each side. And the way you find how many cubes there are is length times width times height. So that would be 10 times 10 times 10. That would be 1,000. So if we divided that by 10, that would be 100. So if we just had 100 cubes, that's our mat again, that would be a tenth of our 1,000 cubes. And if we divided our mat into 10 equal strips, one strip would be a tenth of the mat, but that's a tenth of the cube, so it's a tenth of a tenth, that's 1/100th of the original cube. And you could even divide this strip into 10 pieces, and just one of them would be a unit. And that unit would be 1,000th of the original one, because we divided it into 10 pieces to get the mat, and divided the mat into 10 pieces to get a strip, and divided the strip into 10 pieces to get a unit. So we divided it 10 and 10 and another 10. That's 1,000th. That's how fractions work in base 10. You could also deal with money and talk about powers of 10. Here's an actual silver dollar that I earned when I was delivering papers when I was 14. A tenth of that dollar would be a dime. A tenth of that dime would be a penny. So how many pennies would it take to make a whole dollar? 10 times of pennies to make a dime, and then 10 dimes to make a dollar. So that's 10 times 10. Take 100 pennies to make a dollar. But let's go the other way. If we have a dollar and divide it by 10, we get a dime. That's a tenth of a dollar. And if we divide that dime by 10, we have a penny, which is 100th of a dollar. Probably looks better with decimals. If you divide a dollar by 10, the decimal goes here, 10 cents. If you divide 10 cents by 10, you move the decimal again, and you have 1/100th of the entire dollar. We can expand any number using powers of 10. This digit's in the tens column, so it represents 2 times 10. This digit's in the ones column, so it represents 3 times 1, or 10 to the 0 power. Remember, anything to the 0 power equals 1. This digit is worth a tenth, 7 times a tenth. Or you could write it 7 times 10 to the -1 power. That's the same thing. This digit is in the 100th column, 5 times 100th. But you could write it 10 to the negative 2. That means the same as 100th. See, there's 2 there. That means there's 2 zeros on the bottom, 100th. The negative means it's a little fraction. This negative means it's a little tiny fraction. If it's not negative, it's not a teeny tiny fractional number. Let's talk about those negative exponents again. Here's the rule with all negative exponents. If you see a negative exponent, it means it has a negative attitude, doesn't like where it's at. It wants to be sent to the bottom of the fraction. That 7 squared has a negative attitude. It wants to go to the bottom of the fraction. And there's the answer, 1 over 49. 7 squared is 49. My pen got away from me. Let's look at this one. That x to the negative 4th, the exponent has a negative attitude. It's not happy where it's at, so it's on the bottom. It wants to go to the top. It's going to join the 3 up there on top. There'll be nothing on the bottom, so I don't have to write anything, not even over 1. That's the answer. The 3 is happy, leave it where it is on top. X to the 4th is unhappy, it has a negative attitude, send it up to the top. That's what a negative exponent means. And remember that anything to the 0 power is 1. A to the 0 power is 1 times 7. If the whole entire process is to the 0 power, the whole thing turns to a 1. Let's try expanded form again, and instead of hundredths, thousandths, we're going to write it with 10 to some power. This digit's in the tens column, so it's 2 times 10. This digit represents 7 times 1, so it's 10 to the 0 power. This 1 is in the tenths column, that's 1/10, but we know that's 10 to the negative 1 power. This 3 is in the hundredths column, so you could say 3 times 100th, but if you want to write it in powers of 10, you say, 100, that's 10 squared, it's on the bottom, so it must have a negative attitude, negative 2. This 2 is in the thousandths column, so it needs 3 in its exponent, because a thousandth has 3 zeros. And since the thousand's on the bottom, it must be a negative exponent. All these negative exponent means it's a teeny tiny fraction, a tenth, or a hundredth, or even a thousandth. Let me write out this one in expanded exponential form. We're going to use exponents, not the fractions. That 2 is worth 2 times 10 to the first. 2 times 10, 20. This 8 is worth just 8. 8 times 1, 10 to the 0 is worth 1. Plus this 1 is in the tenths column, so it's 1 times a tenth. And a tenth is 10 to the negative 1. Remember that negative tells us the 10 wants to be on the bottom. I don't need to write 0 or 0, but here's a significant digit, 3. 3 times 10 to what power? Not tenths, not hundredths, not thousandths, but 10 thousandths. And 10 thousandths has 4 zeros, so it's 10 to the negative 4. You could just say to yourself, we went backwards past the decimal 1, 2, 3, 4, and that's why it's to the negative 4th. Let's compute with powers of 10. If you want to multiply something times 10 to the 4th, simply take the decimal. If you don't see it, it's at the end, and move it this many times. That's what 10 to the 4th means. Move it, move it, move it, move it 4 times. And that's the answer. 7,230,000. This tells you how many times to move the decimal. That's the beauty of 10 to a power. Ah, but look at this one. It's a -3. It has a negative attitude. It doesn't want to move to the right and make the number bigger. It wants to move to the left and make the number smaller. So the answer to 10 to the -3rd times 723 is 0.723. I move the decimal 3 times. The next one is a positive exponent. I'm going to move the decimal 3 times from wherever it is. 1, 2, 3 times. If there's no digit, I'll fill in a 0. So this becomes 7,230 because the decimal moved to the end. This exponent's negative. It has a negative attitude. It's not happy where it is. It wants to be on the bottom. 10 squared, that's 100, wants to be on the bottom, times 0.0723. So I'm going to take that decimal, move it this many times, but I'm going to move it to the left 2 times because of that negative sign. I'm going to move it to the left. So this answer becomes 0.000723 because I moved the decimal to the left 2 times.